All right, increasing, decreasing test. If your derivative is greater than 0 on an interval, then your function's increasing. If your derivative is less than 0 on an interval, it's decreasing. Reason is, again, remember, what does derivative find? Rate of change or slope. So if you have positive slope, that means you should be increasing. If your derivative is less than 0, that's a negative number. And so if you have negative slope, that's going to be decreasing. So anywhere where your derivative is positive should be increasing. Anywhere where it's negative should be decreasing. Let's look at one example here. Find where this function is increasing and where it is decreasing. So what you want to do first, find the derivative, because we need rate of change to find this out. If we do that, just using our little power rule here, you got 12x cubed minus 12x squared minus 24x, derivative of 5 is 0, it's a constant. Next, we're going to find those critical values. Even though it's not where it's greater than or less than 0, it does provide us with a place to start. So we're going to set this equal to 0 now and solve it out. On the right side, I see that there is a greatest common factor here. All of them are divisible by 12, and they all have at least one x. So let's factor out a 12x. What's left over then is x squared. Factoring out a 12x here, we got 1x. Factoring out a 12x on the last one, we're going to end up with 2. Let's finish factoring that. And so if we finish factoring, that's x minus 2 and x plus 1. So where are our critical values here then, where it would equal 0? If you put all these equal to 0 now and solve them, divide by 12 here, 0 is a critical number, 2 is a critical number, negative 1 is a critical number. So now to find where they're increasing, decreasing, we're going to go back and use that little trick we've used in the past of using a little number line here, putting those values on there. And don't worry if it's not spaced out correctly. It's just to help us figure out where it's increasing, decreasing. We're going to pick numbers inside those intervals and use those to check them. So let's start on the right-hand side and work to the left. What if we put a number bigger than 2 in there, such as 3? I would not go back to the original to find that out. Easiest place is where you have it fully factored there. So if we put in 3, it doesn't even matter what value it is. 3 plus 1, that's a positive number. 3 minus 2, that's a positive number. 3 times 12, that's a positive number. If we multiply 3 positives, this is going to come out positive there. Let's now check a number in between 0 and 2, like 1. So if we put 1 in, 12 times 1 is positive. 1 minus 2, though, that now turns negative. 1 plus 1 is still positive, but if we multiply 2 positives and a negative, that's going to come out negative. Now we got to test a number between 0 and negative 1. There's no whole number, so check a fraction like negative half. If we did 0 or negative half times 12, that's going to come out to be a negative number. Negative half minus 2 is negative. Negative half plus 1, though, that's still positive, slightly positive. If we multiply 2 negatives, that's a positive times another positive, should come out to be a positive result. We got one last interval to check when it's less than negative 1. So if we put a number in like negative 2, that's negative. Negative 2 minus 2, that's negative. Negative 2 plus 1, that also now turns negative. If all three are negative, if we multiply 3 negatives, we're going to get a negative result. And so now, if we want to say where it's increasing, decreasing, we know those intervals. Let's start with increasing. That would be on our interval from negative 1 to 0. It was positive here. And also union now, 2 on, so 2 out to infinity. Where's it decreasing? Those would be our 2 other intervals here. So it's decreasing from negative infinity to negative 1, and also in between 0 and 2. So those would be our places where it's increasing, decreasing.